Hi, and welcome to this Calculus 1 video. This video will serve as an introduction to derivatives as a rate of change. So before we get into the calculus of derivatives as rates of change, we're going to actually look at how to simplify some of this algebra in maybe a little bit more efficient manner than before, and also the difference quotient, making sure you remember what that is algebraically, so then when you get to your calculus lesson, you can focus on just the calculus learning and not be so consumed with some of this algebra. So let's get right down to number 1. I'm asking you to simplify this expression that we have here. And again, I'm not asking you to know right now where this expression comes from, but we're going to work with this as it's shown. Okay, so x plus h quantity to the fourth minus 5 times the quantity x plus h, that's probably an easy, distribute negative 5. And here I can certainly distribute a negative 1. But I do need to multiply out this binomial x plus h to the fourth. And that would be like me writing x plus h as a quantity 4 times and multiplying this all the way out. I certainly could square it and then multiply and so forth, but it could take a while. This was one of the applications of Pascal's triangle. So let me draw that out for you. All right, here's the first few rows of Pascal's triangle, and this was also linked to our binomial theorem. If you were in a probability section of any course prior, you probably saw this as well. So this row right here that we start with, sort of the tip of our triangle, is our binomial, which in this case I'll call x plus h. It's really a plus b, but it doesn't matter what you call it variable-wise as long as they're two different variables, to the 0th power. These would be the coefficients if you were to take x plus 1 to the first. It'd be 1x plus 1h and so forth. So when you get down here, these are going to be the coefficients of x plus h to the fourth. Now, how do you get this next number? Well, or this next row. So you put a 1 on the corner, right around the end, and then to get the next value, which always will go in between the top previous two, you add those together. So 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and a 1 on the end. And I could do that again. 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 15, 6, and 1. And again, if you look at the two kind of kitty corner above each number, that's where that sum comes from. So I'm going to be looking at this row right here, and usually Pascal's triangle can be written out within a matter of a few seconds. So that's why this becomes really efficient. Then what happens, so I'm going to write out all those coefficients here. So it's going to be 1, 4, 6, 4, 1. And again, I'm trying to just take x plus h, that binomial, and raise it to the fourth. So then my first variable or first term in that binomial is going to be descending in terms of powers. So that'll be x to the fourth. The next term will have x cubed, then x squared, then x, and then no x. Then our second term in that binomial, in this case h, will be ascending in terms of degree or powers as I look through. So no h's, h to the first, h to the second, then h to the third, and then h to the fourth. Again, it is important that you start with a 0 power. Now also, we looked at the degree of each term before. The degree of each term was the sum of the exponents within each term. And that should be 4 for every single term. 4 and 0, 3 and 1, 2 and 2, 1 and 3, 4. So they should all add up to 4. And you know you've kind of done it right. Now there was a addition in between for my binomial, so all of these will also be positive values. There's no reason that they're negative. And now, with very little effort, I just expanded the quantity x plus h to the fourth. Then I will distribute the negative 5, so now I'm on that part. Negative 5x, negative 5h, and then I'll distribute the negative to this last green part. So that will be negative x to the 4th plus 5x. This is all over h. Simplifying, let's see here, I can combine like terms. I can combine 1x to the 4th and negative 1x to the 4th. Those add to 0. I can add 5x and subtract 5x. Those add to 0. Let's write what we have left. 4x cubed h plus 6x squared h squared plus 4xh cubed h to the 4th. And don't forget about that minus 5h there, all over h. And you might think, oh great, I'm done. Not quite. So simplify, well, you can't necessarily combine any of these terms together, but what I hope you do recognize is that each term has an h in it. So I will factor it out in order to see its division. Do not just scratch things out randomly. You will make errors. So that leaves me, if I factor it out of the numerator, that leaves me with 4x cubed plus 6x squared h, because one of those is going to come out, 4xh squared plus h cubed, and then lastly a minus 5. Then h divided by h is 1, and so this should simplify to 4x cubed plus 6x squared h plus 4xh squared plus h cubed minus 5. It doesn't necessarily look any more simplified. I have gotten rid of my fraction for one thing. I've gotten rid of all the parentheses for another. I've combined like terms when I could. I did actually add a few of those to 0. And that's it. So Pascal's triangle can help you out immensely. All right. Let's look at number 2 here. Find and simplify the difference quotient for this function. Well, first of all, do you know what the difference quotient is? So let's write that out. The difference quotient is f of x plus h minus f of x all over h. Again, we'll talk about the calculus behind that within this section or within the lesson. But right now, we're just trying to work on the pre-lesson part, things that hopefully you worked on in a pre-calc course, and this will get you ready for your calculus class. Okay, here's the function we're working with. So when it's talking about f of x, it's talking about this function here, 1 over x minus 5, that reciprocal function. But f of x plus h, let's figure out what that is. Well, f of x plus h means instead of the x, you're substituting in x plus h. So it'll be 1 over, and in place of this x, I'm going to put x plus h. It's still in the denominator, so now I just have 3 terms in my denominator instead of 2, but there's really no simplifying or anything else I can do with that. Can't combine any like terms. That's pretty much it. So I'll go to my difference quotient formula. So if it's f of x plus h, I've got that, minus your f of x, so it's minus the original, all over h. And I'm going to make this really exaggerative so you can see I have a complex fraction because I have rational expressions or fractions in my numerator. So I'm going to need to work on those a little bit. Now you certainly can get a common denominator, go through that process, multiply by any reciprocals, do whatever you need to do to simplify that complex fraction. I like to take whatever it is my LCD is, so I'm going to figure that out, and then I'm going to multiply that LCD by the numerator and denominator, because then I'm just multiplying by a factor of 1. I'm changing the way that this expression will appear, but I'm not changing the value of it. So let's take a look. What would our common denominator be? Again, really any common denominator would be fine. I'm going to try for the lowest though. Well, this first denominator is an all or nothing, right? Because that's just that whole denominator is one factor. So x plus h minus 5 is a whole factor coming together. Then x minus 5 is also a factor. And again, if you had a denominator of 2 and a denominator of 3, and you were adding these together, nobody really cares that the 3 is 1 more than the 2, right? So it doesn't matter that this is 2 plus 1 and that there's a 2 in there because that's a sum. So when you're looking at factors, you would have to take both the 2 and the 3. So hopefully that reminds you of what we're doing. So I'm going to take that common denominator and I'm going to multiply that by the top, so by the numerator. It's kind of like over 1. And I'm going to multiply that in the denominator. Again, as long as you multiply by something over itself, and again, this matches, right? Then I'm multiplying by a factor of 1, and I'm not changing the way its value, I'm just changing the way it will appear. Okay, so if I distribute both of these factors to each term in my numerator, in the first term, this x plus h minus 5 is going to divide to 1, leaving me only with the 1, right, this 1, and the x minus 5 factor. Minus, this numerator is a 1. And then the x minus 5 factors now would divide out, right, if I distributed, leaving me with the x plus h minus 5 factor all over. And I'm not going to multiply out this denominator, which I'll talk about now. Oops. Now, why didn't I multiply out the denominator? Well, we like to see domain restrictions, which comes from where is our denominator equal to 0, number 1. Number 2, we really like different expressions in factored form. That denominator is perfectly factored. And number 3, I'm probably going to have to do some simplification here when I'm done, which when we get to the calculus lesson, you'll learn why. So I want to keep that denominator in factored form so I have a chance of simplifying it later. So I'll distribute these coefficients. I understand that distributing a positive 1 does not change a value, but be very, very careful. You are subtracting the second fraction, right, from your difference quotient. You are supposed to subtract. And what often gets lost in the shuffle is that whatever that numerator is, that is your distributing value to whatever is going to be left over. So I need to distribute this negative 1 throughout those parentheses. So it'll be minus x minus h plus 5. And I'm going to copy down the denominator. All right, so what is this? Well, these x's add to 0. X, negative x. And then I have positive 5, negative 5 adds to 0. So the only term left in the numerator is negative h. And I can certainly see now why I did all of that. I can simplify this, right? So I can divide h by h to be 1. And I have found and I have simplified the difference quotient for that problem. Now again, this might not have a whole lot of meaning to you right now, but we are for sure going to use this in our notes for that lesson and in our discussions, and we are also going to use this part in our discussion for derivatives as a rate of change. So I hope this algebra is somewhat familiar to you. The one thing you may have to look up maybe is Pascal's triangle, which we used in number 1. Okay, maybe that will refresh your memory enough. Maybe you can look it up further. And also the difference quotient for number 2. Maybe you need a little bit more practice on that, but this should be enough to get you started. Thanks for watching.